Welcome to Subeezy, Subjects Made Easy. In this algebra lecture, we will discuss quadratics. A quadratic is an expression where the highest power in the variable is 2. It contains some variable raised to the second power. Note, if an equation contains a higher power, such as a variable raised to the third power or a variable raised to the fourth power, it is no longer a quadratic. Consider the following. X squared is equal to 16. This is where our understanding of exponents becomes important. Recall from a previous lecture that if we take the even root of a number, we will be left with two answers, a positive and a negative. So to solve for x, and x squared is equal to 16, we need to take the square root of both sides. By taking the square root of x squared, we will cancel out that exponent. The square root of 16 has two possible answers, a positive 4 or a negative 4, because positive 4 times positive 4 is equal to 16, and negative 4 times negative 4 is equal to 16. Understanding that we get two answers is essential for solving quadratic problems. For many quadratic problems, you will end up with two possible answers. Before diving into some of the complicated quadratic problems, let's start with a basic warm-up. If x squared minus 4 is equal to 0, and x must be greater than 0, what is the value of x? X squared minus 4 is equal to 0. If we add 4 to both sides, we end up with x squared is equal to 4. To get rid of that squared, the exponent on our unknown variable, we take the square root of both sides. The square root of 4 results in positive 2 or negative 2. However, we were told an important piece of information, that x is greater than 0. This means that x must be positive. Therefore, even though by taking the square root of 4 we end up with two possible answers, there is only one possible value for x. The answer x is equal to negative 2 is not a valid option. The only possible value of x is positive 2. You must pay attention to any additional information that you are given, especially when it comes to quadratic problems. Now let's consider a slightly more difficult problem. If the quantity x plus 2 times the quantity x minus 6 is equal to 0, what is the value of x? To solve this, let's think about it in terms of variables. So take the first quantity, x plus 2, and let's call it a. And take the second quantity, x minus 6, and call it b. This equation is saying that when we multiply a and b, we get 0. A times b is equal to 0. In order for the product of the two numbers to be equal to 0, at least one of the numbers must be 0. If a is 0, then it doesn't matter what the value of b is. The statement will still be true. 0 times b is equal to 0. And if b is 0, then it doesn't matter what the value of a is. The statement will still be true. A times 0 is equal to 0. So for our quantity x plus 2 times the quantity x minus 6 is equal to 0, either x plus 2 or x minus 6 must be 0. So let's consider x plus 2 first. If x plus 2 is equal to 0, then 0 times the quantity x minus 6 is still going to be equal to 0. So if x plus 2 is equal to 0, what is the value of x? Well, if we subtract 2 from both sides, we end up with x is equal to negative 2. If x is equal to negative 2, then this entire equation will be true. So negative 2 is one possible value of x. Now let's consider if the quantity x minus 6 is equal to 0. If the quantity x minus 6 is equal to 0, then the quantity x plus 2 times 0 will be equal to 0. In order for the quantity x minus 6 to be equal to 0, x will need to be equal to positive 6. If x is equal to positive 6, then this equation will be true. So positive 6 is another possible value for x. Again, recall that when you're dealing with quadratics, you will often end up with two possible values for your unknown variable. So let's answer this question. If the quantity x plus 2 times the quantity x minus 6 is equal to 0, what is the value of x? X could be equal to negative 2 or positive 6. Let's check by plugging these in. If x is equal to negative 2, then we end up with negative 2 plus 2 times negative 2 minus 6. We end up with 0 times negative 8, which is equal to 0. And if x is equal to positive 6, then we have positive 6 plus 2 times positive 6 minus 6, which is 8 times 0, which is equal to 0. It's important to always double check your answers by plugging in those values back into the original problem. Next, we're going to consider another way that quadratic equations can be presented. Consider the same equation. The quantity x plus 2 times the quantity x minus 6 is equal to 0. What if we distribute this first? Recall from our previous lecture on distribution and factoring, the FOIL method, which stands for first, outside, inside, last. So we're going to first multiply the first terms, x times x, which is equal to x squared. Then we're going to multiply the outside terms, x times negative 6. It's important that you do not forget to multiply by negative because we have x minus 6. So we end up with negative 6x. Next, we're going to multiply the inside terms. 2 times x is 2x. And then finally, we're going to multiply together the last terms. 2 times negative 6, which is equal to negative 12. After we have used the FOIL method to get each of these terms, we then add them together. So if we distribute the quantity x plus 2 times the quantity x minus 6 is equal to 0, we end up with x squared plus negative 6x plus 2x plus negative 12 is equal to 0. And let's simplify by combining like terms. Negative 6x plus 2x is equal to negative 4x. So our final equation is x squared minus 4x minus 12 is equal to 0. Most often, quadratic problems will present the equation in this form, rather than the two quantities being multiplied together. If we were originally presented with this equation, x squared minus 4x minus 12 is equal to 0, it would be difficult to tell immediately that this equation is the same as the quantity x plus 2 times the quantity x minus 6 is equal to 0. To figure out how to convert x squared minus 4x minus 12 is equal to 0 to the quantity x plus 2 times the quantity x minus 6 is equal to 0, it is helpful to consider x squared minus 4x minus 12 is equal to 0 as a x squared plus b x plus c is equal to 0, where a, b, and c are the coefficients. So for our equation, x squared minus 4x minus 12 is equal to 0, a is equal to 1. There's a 1 in front of the x squared. B is equal to negative 4 because we have minus 4x. And c is equal to negative 12. Pay attention to any minuses in your equation. You do not want to forget to include them if they are there. To go from x squared minus 4x minus 12 is equal to 0 to the quantity x plus 2 times the quantity x minus 6 is equal to 0, you need to have one important skill. You need to find two numbers that when multiplied together equal c and when summed equal b. So now we're going to identify those two numbers for this problem. We said that c is negative 12 and b is negative 4. First, we want to find all the possible factors of c. c is negative 12, so the possible combinations of factors are 1 times negative 12, negative 1 times 12, 2 times negative 6, negative 2 times 6, 3 times negative 4, and negative 3 times 4. After you have identified all of the possible factors of C, the second step is to identify which pair of factors, when summed together, will equal B. B is negative 4. So which pair of factors here, when added together, are equal to negative 4? 1 and negative 12 when added together are equal to negative 11, so that pair does not work. Negative 1 and 12 when added together are equal to 11, that also doesn't work. 2 and negative 6 when added together equal negative 4. That's the pair we're going to want to use, but let's continue practicing this with the other pairs. Negative 2 and 6 when added together are equal to 4. 3 and negative 4 when added together are equal to negative 1. And negative 3 and 4 when added together are equal to 1. So the pair that we're going to want to use is 2 and negative 6. When we multiply 2 and negative 6, we get negative 12, which is C, and when we sum 2 and negative 6, we get negative 4, which is B. So to go from a quadratic that is written with x squared to two quantities multiplied together equaling 0, start by writing two quantities, x plus blank and x plus blank. We can fill in these blanks with the factor pairs of C that when added together equal B. So we can fill in these blanks with 2 and negative 6. We end up with x plus 2 times x minus 6 is equal to 0, which is the same thing as x squared minus 4x minus 12 is equal to 0. This is how you factor out a quadratic, and this skill is absolutely necessary to do well on your exam. This method is perfect if the coefficient of x squared is equal to 1. That is, a is equal to 1. But what if a is not equal to 1? Consider the following quadratic. 3x squared minus 18x minus 21 is equal to 0. We see that a is equal to 3, b is negative 18, and c is negative 21. In order to factor out this quadratic, we must first factor out the 3, which is what a is equal to. We can pull out a common factor from the three terms. In this case, a, b, and c are all divisible by 3. When we pull out 3, we end up with 3 times the quantity x squared minus 6x minus 7 is equal to 0. And now in the parentheses, we have a quadratic expression where the coefficient of x squared is equal to 1. X is equal to 1. Now we're going to solve everything that's in parentheses the same way that we just did in the previous practice problem. So let's take our quadratic equation, 3x squared minus 18x minus 21 is equal to 0, and factor out the value of a, which is 3. We end up with 3 times the quantity x squared minus 6x minus 7 is equal to 0. So let's just focus on what's in parentheses. X squared minus 6x minus 7. Recall the first step is to find all of the factors of c. C is negative 7. We have 1 times negative 7 and negative 1 times 7. Second, we need to identify which pair of factors of c, when summed together, equal b. B is negative 6. The factor pair that when added together equals negative 6 is 1 and negative 7. So now we take our two quantities, x plus blank and x plus blank, and fill them in with the two values of the factor pair of c that when added equal b. We end up with x plus 1 times x minus 7. So going back to our original quadratic, we factored out a 3, and then we're going to replace what's in parentheses with these two quantities. We end up with 3 times the quantity x plus 1 times the quantity x minus 7 is equal to 0. For these three quantities to multiply together and equal 0, at least one must be equal to 0. Well, 3 is equal to 3. It cannot be equal to 0. X minus 7 can be equal to 0 when x is equal to positive 7. And x plus 1 can be equal to 0 when x is equal to negative 1. So for our original quadratic, 3x squared minus 18x minus 21 is equal to 0. The values of x that will make this true are x is equal to positive 7 or x is equal to negative 1. If you notice, all of the quadratic equations that we have dealt with so far have been set equal to 0. If you are ever presented with problems in this form, x squared minus 4x is equal to 12, where c is on the other side of the equal sign, before you start factoring your quadratic, you must move everything to the same side of the equation and set the equation equal to 0. So we can subtract 12 from both sides, and we end up with x squared minus 4x minus 12 is equal to 0. And now you are ready to solve the quadratic. An important note about quadratics is that you should not assume that every quadratic equation will always have two different solutions. Consider the following. X squared minus 8x plus 16 is equal to 0. When we factor this quadratic, we get x minus 4 times x minus 4 is equal to 0. So x could be equal to positive 4 or positive 4. Therefore, x can only equal positive 4. This quadratic only has one possible value for x. And also notice when we factor this quadratic, we end up with the same quantity being multiplied by itself, x minus 4 times x minus 4. We can rewrite this as the quantity x minus 4 squared. This is called a perfect square quadratic. Both roots of the quadratic are the same, x minus 4. Now let's move on to discuss when you have quadratics and fractions. Whenever there is a fraction and the denominator is equal to 0, the number is undefined. For example, 5 divided by 0 is undefined. You cannot divide a number by 0. Knowing this, let's apply this to quadratics and solve the following. We have x squared minus 4x minus 12 divided by x minus 3 is equal to 0. We have seen this numerator twice in this lecture. We know that it factors to the quantity x minus 6 times the quantity x plus 2. Therefore, we can rewrite this quadratic equation as the quantity x minus 6 times x plus 2 in the numerator divided by x minus 3 is equal to 0. What values of x can make this equation true? A fraction will equal 0 if the numerator is 0. In this equation, if x is equal to 6, then the numerator will be 0. And if x is equal to negative 2, the numerator will be 0. X could be equal to positive 6 or negative 2 to make this equation true. But note, if the denominator is equal to 0, the answer is undefined. Therefore, x equals 3, which makes the denominator equal to 0, is not an answer. Whenever you are presented with a quadratic problem with a fraction, you must always identify which values of the unknown variable will result in an undefined expression. Now let's summarize this lecture on quadratics with the key points. First, when the highest power in an equation is 2, for example x squared, you have a quadratic equation. Second, to solve quadratics, first move everything to one side and set the equation equal to 0. Then find the two factors of c that when added equal b. Think of the equation we used in this lecture. X squared minus 4x minus 12 is equal to the quantity x minus 6 times the quantity x plus 2. And third, whenever 0 is in the denominator, you have an undefined number. If you solve for x and get one value that causes the denominator to be 0, that value for x is not a possible answer. This concludes the Subeezy lecture. Thanks for watching and be sure to do the practice problems.